Okay, so let's say we have two particles of mass m, and they are moving, they have a component, so this one has a component, a velocity component of, say, c over 2 that way. This one has a velocity component c over 2 that way, but they both also have a velocity component of c over 2 in that direction, in a direction perpendicular to the horizontal direction. And so they obviously will come together, right? They're moving like that. And so they come together, they collide. And let's find the post-collision mass. Okay, so we need to build, and in this case, we have a 4 momentum, right? So we will have a gamma mc. We have an x component, so we have a gamma mvx and a gamma mvy, say in 0. So this is the x direction, this is the y direction, and out of the page is the z direction, but we have 0 z velocity. We need the gamma factor, and they will be the same for both objects. So what we have is, right, we have a velocity component of c over 2 this way and c over 2 that way. So what's the gamma factor for these two objects prior to the collision? Well, we have a speed which, right, it's just Pythagoras theorem, so we have c over 2 squared plus c over 2 squared square root, and that gives us right, so c squared over 4 plus c squared over 4 square root, 2c squared over 4 square root, that's c squared over 2 square root. And so we have c over square root of 2. And the gamma factor associated with that is 1 over 1 minus. We're going to square that, so we'll get a half. We'll have a half square root, so that is 1 over the square root of a half, and so that's just square root of 2. So the gamma factor is square root of 2, and so our two velocities will be square root of 2. So for the object on the left that's moving to the right, we have square root of 2 mc, square root of 2 mc over 2 for the x component of the momentum, square root of 2 mc over 2, because we have a y component, and we're going to add that to the 4 momentum of the other object, which is square root of 2 mc, square root of 2 minus mc over 2, because it's a leftward component, and then square root of 2 mc over 2, and then 0, and we add these two together to get a net 4 momentum, which is equal to 2 root 2 mc. These two add up to 0. The y component adds up to root 2 mc, and then we have 0, and that has to equal to the final momentum in the form, the final momentum, the post-collision momentum in the form of so let's just write this out again. So we found that the total for momentum is 2 root 2 MC, 0 root 2 MC, and 0, and this has to equal to some gamma, new gamma. After the collision, the object will still be moving, so that's not 1. We have a post-collision mass, let's call it MP times C. Well, this is 0. That can be written as MP times the y component of the velocity and 0. And so the first equation gives us, the first term gives us 2 root 2 m equals gamma MP. And we're trying to find what MP is. And so the second equation, we have to go to the second equation, which is the third component here, which says that root 2 MC is equal to gamma MP Vy. And so we can get the Vy from this. The Vy is also in here, but right, well, let's just replace this. So let's just rewrite this second equation. So we have this equation and this equation. Here we have root 2 MC is equal to gamma MP, which is 2 root 2m, and that's times Vy. And so we can get from this that Vy is equal to C over 2. And so the gamma factor here must be 2 over root 3, associated with the speed C over 2. And so we can find, so we know what gamma is now, and so we can get, this equation becomes 2 root 2m is equal to this gamma times MP, and therefore the mass post-collision is equal to root 6